All right. What you're seeing here is actually the continuation of what we did last time when we started to do some canvas animations. This is actually not very far from what we did last time. We only added a couple of things here. We added lines between the dots. In the last step, we ended with dots that animate and move, but here we have lines between the dots, and you can see that the lines grow thicker as the dots come closer, and we also have, and also in the, you can see this blue grid we have in the background also. That is actually a visualization of an optimization I've done. It's actually a kind of debug display here. The thing is that to do this line, we need to find what dots are close to each other, and if we have a lot of dots on the screen, it can be very tedious for the computer to like measure the distance between every dot to every other dot. So like if we have 1,000 dots, then we will have to do 1,000,000 computations to compare each dot against each other dot. So one way we typically do this in programming when we do graphical information systems and such is we do either a quad tree or a octa tree, or in this case a binary space partition tree, and that is, you see the lines, the middle line here is a little bit thicker, and then they get thinner and thinner, and that indicates that we actually have a tree structure. I can show you like here. First we split the screen horizontally, and then we split it vertically, and then we split it horizontally again. So we can have a structure, and each of these dots can be in this tree. And so like if you have a node on the far side here of the graph, and you want to compare it to a node on the other far side of the display, then they don't have to compare each other, because you can see this whole part of this subtree can be ignored if you compare something that lies out here. So that's an optimization that we'll go through lastly. To start with, we should just go back to where we left off when we did the first animation. So yeah, let's walk it through from the beginning. So I have here, let me see, let's run that one. npm run dev was the name there, and then now it reloads, and now we get the dots we ended with last time. So now we should walk through this, how to do this. Yeah, so the first thing, we can do a couple of things first to get started. First of all, we can just go to package.json here. Instead of having to run, having to type npm run dev, we can just have the start command, like so. Now we can just type npm start when we want to start this one. That's the first thing. Another thing that we can do also is that, let's go to main. Let's restructure our program a little bit. The dot could actually be in a file of its own. It's a little bit, you end up with a lot of things in the same file. It's not good developing practice. But it can be in the beginning. It's like, why clean up before you make a mess? It's like, sometimes it can be good to put everything in a file, do something quickly just to try things out, and then we see that it works, then you can try to get more structure behind things. Here's the dot. Now we want to link that to this file. Did it link? No. Ah, yeah, because we forgot to export it here. We go here. Yeah, now we can see, now we can get it imported here directly. This is the benefit of doing a proper Vite project that builds. We can get these imports and stuff and structure our file a little bit. Just make sure it still runs. Okay, we want to draw lines between things, but how do we do that? Now in the main here, we need to find out if dots are close to each other. So we need to before we draw the dots, we need to dot. We need to connect it to all other dots. And now we can. One thing here is like, if you connect dot A to dot B, you don't want to also connect dot B to dot A. So one trick to do this here, you could have two connections, but it's unnecessary because we just want one line. And one very easy way to prevent this is we do like this. We have an ID number. Let next ID equals 1. Let's give each dot an ID number. Sometimes it can be good to give things an ID number. This ID equals next, like so. And now we want to, before we move things, we want to connect. And we have a list of dots, and the dots. We can just filter the dots and to see which one is connected. We can, in here in the constructor, we can say that this. We can set it to null to begin with. But when you connect the dots, we filter the dots on all dots that are it should have an ID higher than this. Let's do the opposite way around. The ID of the dot should be higher. This first of all prevents that you connect to yourself, because there's an inequality here. So what this means is that for two given dot IDs, one is higher than the others. In this way we'll only get one of the connections. But also there should be some other requirements, and that is, we need to measure distance between. We can do that. That's basically Pythagoras equation. We need to have a distance function to the other dot, and that is. Let's just copy paste that from the original solution. This is not so super interesting, so we just, for those who wish to implement it, of course, we can have a quick look. Okay, what's happening here? We have the delta x and the delta y, and then we do square root and we multiply them. Pythagoras. We don't need the abs here. I just realized, like so. Okay, because we're gonna multiply them by themselves anyway. Okay, so let's see here. We have dot this distance to this or this. Let's do it opposite way. Okay, this distance to dot should be above or below some value, and this we can create a constant of here. Or the maximum line distance. The maximum distance for when there is a line. No, here. Alright, if the distance is smaller than the maximum line distance, then we should add this to the filtered list. So that should be it, and so now we have connections set to here. So let's see in the main, we connect each dot, maybe we could also do that in a. Could it matter if we connect dots after? No, it should be fine actually. Okay. Yeah, I was thinking if we should loop through all the dots and do this connection before we draw each dot, but I think this will work anyway. Okay, let's see, and now we need something in the draw to draw this line. Again, I don't remember all the drawing commands here, so just let's have a look at what we have here prepared already. Let's remove that one. Okay, so what's happening here? Okay, so we have the connections for each connection. This is another way to loop through strings in a JavaScript, that you do a for each of the things in a list. Before we usually use the for loop, but this is actually a little bit more performant, I think actually. But okay, okay, so we have the distance to the other dot again. So we get the distance, and we have a strength here that depends max distance connection. That should be our maximum line distance. Okay, so we get the percentage here of how that starts with 100% and ends with 0. As more close you get to this maximum line distance. Strength. No, this is weird. Maybe there's some leftover here. Okay. Ah, yeah, this is maybe maybe to get some rounding correct. I don't know. Okay, anyway, we begin the path. We set line width to 10. 10 is the maximum strength, and 0 is 1. So we set the line width here to a value that is between 1 and 10, and then we set this stroke color to color, that is this is white, but essentially, and with a semi-transparency, that is strength, and then we move to this dot, and then we line to the other dot, and then we just call stroke here. So those are the commands here that happens. So let's try this now. Scary. It's always scary to run stuff when you are a developer, because you never know what's going to crash and what bugs you encounter. So let's try it. npm start. Maybe I didn't have to run it again, but I did it anyway. Okay, so nothing happened. Okay, yeah, that's just what I'm talking about.